Hello, everybody. Welcome to our Secure Web Dev Workshop. I'm Arin, and
I'm Sophia. Sorry.
thank you.
I'm Unifon or Ufa.
All right, if you want to follow along with us, you can follow this link, links.uclaacm.com/secure, what does that say? Secure Web 21. And I think the link is a little bit slow, but you will definitely get there. And you can follow along with us if you want to. All right. So here's our outline. We're going to cover some basic stuff, how you can use libraries to protect your web application. And then, of course, we're going to touch on some of the amazing cybersecurity concepts we talked about this quarter. And we'll show you the opposite of what you should do to hack it, which means to protect it. So we're going to start with Sophia.
Okay, so I'm going to be covering basically just the general outline of what makes a secure app. And these are all taken from OWASP standards. OWASP stands for Open Web Application Security Project, and they have a really neat set of guidelines. And a lot of them boil down to just be as restrictive as possible in everything. But of course, there's nuance to that, so we'll look into that. So on the user side, you always want to make sure you validate their input. Make sure they're not trying to put code into your stuff, or maybe put null bytes that could possibly break how you process their input. And if you have to allow risky characters that could potentially be code, make sure that everywhere that input is used in your code, you've really accounted for it and you're very thorough in checking it, and you're very restrictive on the access of that input to processes in your code. And then when you're allowing users to upload files, one thing we've learned from our fall workshops is that file extensions can be total liars. So if you want to actually check what type of files they are and see if, okay, should my web app allow this file to be uploaded, you got to look at the headers. Also, you always want to make sure to be very thorough about user authentication. So only perform user authentication processes on trusted servers, not in source codes. Trusted servers also for password hashing, which we'll cover later. And nobody wants to annoy their users, but it's better to annoy your users by asking for re-authentication when you're undergoing really sensitive processes, especially for banking or money transfer or anything that really could jeopardize them. Ask for re-authentication rather than taking a shortcut. Next slide. More on kind of restrictions, particularly with user input. You really want to strongly type this. Make sure they're not giving you something that your code can't handle. And you can set limits on length and range. And then also typing goes beyond just how you handle user input, but also how you handle querying your database. You want to keep your database as functional and as basic as possible so that you know everything that goes on with it. Don't opt for the default settings of your database. You have to make sure you have a handle on exactly how it functions, and how you handle control. How much a user or a user can access your database should be tailored to their trust level, which we'll talk about in more detail later. Next slide. Random means random. So if you're trying to generate random IDs for user sessions or file uploads or user IDs, you have to make sure the algorithms you pick actually generate random IDs, because if some outside player can guess those IDs because they're not truly random, you're in for a load of trouble. And to take it even further, extra layer of security for extra sensitive processes, and Erin will talk about this later, but you can also introduce tokens, which are furthermore random, and those will be an extra layer of authentication. And then also encrypt everything. You don't want to be storing stuff in plain text in your databases. That is a no-no. If you look at our newsletter, you'll see an example of when I bit somebody in the butt. So next slide. In terms of error handling, user does something that causes an error. You don't want your application's response to that to reveal sensitive information, you don't want it to spit out user ID or details about your object that's handling this particular process. Make it as sanitized and kind of as vague as possible while still helping the user figure out what they did wrong. And if there are failures in your code or like an authentication or your code denies a file upload, you want to make sure that is thoroughly logged. And then another thing is keep everything updated. You know, when something has a known vulnerability and people find out about it, they issue patches and then people will know about that vulnerability and be able to go after those who don't update. So you want to keep your servers, your frameworks, all system components that are used in your web application. You want to keep those up to date, use the latest version, make sure you get those patches, and always renew your TLS certificate. So this is the certificate issued to you for your secure socket layer connection. Basically, this just handles like making a secure connection for your website. A lot of people allow this to expire and don't realize it. Equifax did and ended up costing people millions, and it's a whole fiasco. I actually visited one of our ACM websites a couple days ago, and they had allowed their TLS certificate to expire. So it's more likely than you think. Next slide. And then, you know, it's kind of hard to consider all these little factors yourself. So there are libraries to help you in developing securely. OWASP, our wonderful guideline provider, has a framework themselves. It's free. It supports many like common languages, Java, PHP, Go, a couple others. And it protects against common vulnerabilities, which we'll discuss in more detail later. Django is specific for Python, and it protects against those common attacks, CSRF, SQL injection, cross-site scripting, but it also provides like additional functionality. It helps you with user authentication and restricting user access based on their trust level. And then finally, for those of you who use .NET, which I didn't think was that common, but apparently is, Asp Net Core comes very highly rated. It does the standard protections like against those common attacks, SQL injection, cross-site scripting, but it also provides some additional perks. It makes your data encryption very easy. So that encrypting we talked about earlier helps protect your user's data and your application's data. It helps with user authentication. So not just with your database, but also with like external providers. So, you know, whenever you log into something and you see the option log in with Facebook or log in with Google, or I've seen some really weird ones, but apps.net can help with handling those authentication processes. And just like the Django, it also lets you restrict access to databases based on trust levels. Next slide.
All right, so I'm going to take you through nice little throwback a couple weeks ago when we learned about cross-site scripting and CSRF. There are a few ways to mitigate all of that and to protect a potential web application. When it comes to cross-site scripting, the idea behind any protection that you want for this is to deal with data that we don't trust or untrusted data. Don't put it anywhere it shouldn't go. And where you do know it'll be, you want to make sure that it's properly protected. And the way that we deal with that is to encode it. And the way we encode it is for some certain characters, which you can see in the table. We give them a special representation, which is called like an entity. So you can see like, for example, the ampersand becomes like ampersand hash 38. So if someone were to try to send in like an injection, you know, the server will read it as its encoded version, so it won't accidentally run like a script or whatever. It'll just read it and process it that way. Yeah, so there's a couple ways we can use encoding in our potential, you know, protected web application. The main way, the one that I think covers like a lot of basic like protection, is to encode 5 special characters that may exist in our HTML body, which is the ampersand, the less than and greater than signs, the double quotes, and the single quotes. Then there's also attribute encoding, which is whenever you have to send something through a form. For example, let's say like I need to put my age in, so I put like 27, then it sets like some attribute called age to 27. You want to make sure that any non-alphanumeric characters encoded in that # number format, which was just on the previous slide, and also shown in this meme where an apostrophe or single quote becomes the # x27. You can also encode special characters in CSS, JavaScript, and in the URL. I'm not going to really get into that, but those are also places you can encode characters. For JavaScript especially, you don't want to put any data or data that you don't trust, like not in quotes. So anytime you deal with something you don't know, you need to put it in quotes and then you need to encode it. And a lot of this can be achieved with the library, which, yeah. But that's pretty much it for XSS. When it comes to CSRF, the main strategy, the main protection is to use tokens. So I'm going to walk you through a specific type of token, which is called a synchronized token. And CSRF tokens basically just allow a server to identify a request coming in, and so they'll know that it belongs to like the user and not like some outside hacker person. If you're familiar with iCarly, if you're not, that's totally fine. But let's say we have Spencer, who's in the red shirt. He needs to get spaghetti tacos for dinner to feed Carly and her friends. But let's say he's in a bit of a rush, so he has to go get some from the spaghetti taco bank instead of cooking it himself. And let's say there's like a special way to do it where you can order it virtually and it'll show up. So he logs into his account with the spaghetti taco bank, and the spaghetti taco bank will see that Spencer started a user session and will send him a special spaghetti token that's just for Spencer. It's going to live on Spencer's browser, and every time Spencer tries to send a request, the token will go with the request, and so the spaghetti taco bank will know that that request comes from Spencer. So let's say Spencer wanted to withdraw 2 spaghetti tacos from his account. So he'll send a request. The request will say, spaghetti taco token from Spencer, I want 2 tacos. Spaghetti taco bank will say, all right, here's your 2 tacos. Now let's say somebody named, yes, spaghetti tacos are supposed to be crunchy. That's why they have the crunchy shell. Now let's say Neville, some evil boy named Neville, who dislikes Spencer because Spencer foiled his plans to run a haberdashery, decides I'm going to steal some tacos from Spencer's account. So he sends a funky little link that Spencer might accidentally click on, and that link might actually just say like, hey, Spaghetti Taco Bank, Spencer is trying to send 2 spaghetti tacos to Neville's spaghetti taco account. But when Spencer clicks on the link, that link does not have Spencer's token associated with that request. So the spaghetti taco bank will see some request called send tacos to Neville, but it doesn't have Spencer's spaghetti token. So the spaghetti taco bank will say, this isn't from Spencer, this is sketch, I'm not going to send these tacos. So Neville doesn't get his tacos. And yes, because Neville does not get his tacos, Spencer will rue the day. There's a couple other ways we can mitigate a CSRF attack. We can also use cookies. There's a cookie can be set with a same site attribute, and that attribute can be set to strict or lax. And if it's strict, if you're logged in somewhere and you try to access another site with the same login credentials, it might just be like, if it's strict, it'll be like, oh, you can't do that, and you log in again. If it's lax, then it'll let you do that. The double submit cookie is kind of a complicated process, but basically when you initiate a login session, like when a user initiates a login session, the server will send back 2 cookies, one with the session ID and one with a special CSRF token value. So when the user makes a request, it'll send back a cookie and a token. So it creates a token with that CSRF ID value. And so that token will get sent back, as well as the cookie with the session ID. You can also, the server can also analyze the headers for different requests. So the HTTP header is kind of cool because it gives us information about where a request is coming from and where it's going. So if you want to know where it's coming from, if it's like coming from somewhere sketchy, you don't want to process it. Custom request headers are not super necessary, but I suppose if you do want to format it in the way that you want, so it gives you the information you want, you might want to do it yourself. Lastly, this is kind of important, but the cool thing, or not super cool thing, about CSRF protections is that any cross-site scripting attack will mitigate CSRF protection. So you need to include both of them if you want your website to be like properly secured, because you don't want to spend all of this time going through all these CSRF protections and then somebody sends in a cute little like XSS script and suddenly your whole website's like dead, which would not be great. All right, so I actually do have a demo for you. For those of you who went to the CSRF/cross-site scripting workshop, you might have remembered the story of Bob, how Bob basically ran over Hacker's dog. And so Hacker got mad and Hacker basically stole all of Bob's money. Well, I got some news for you. Bob was innocent. It wasn't Bob who ran over the dog. It was one of Bob's brothers. I don't know which one. Could have been Bobbert or Bobby Pattinson or Boob or somebody. I don't know which one of them, but one of them did it. And so Bob is angry. He calls up the bank, pretends to be like an angry carrot saying, hey, you need to protect your website. I got all my money stolen. And so the cool thing is the bank basically goes and inputs some CSRF protection. And I actually have the library pulled up for you. So basically, Node.js has CSRF protection that you can just include if you're trying to make any kind of like web app. And it's pretty simple. Basically, you just use this CSRF function, and that creates a CSRF token, and then you can use it however you want to create your website. There's a couple different options. If you include cookie, like the cookie parameter in the function, that basically means that you want to use that'll allow you to use the double submit cookie technique that I just talked about. If not, you can just use like the synchronizer token technique that I talked about with the spaghetti tacos, which is what the bank did when they secured their website. If you scroll down, there's also some example code, basically. So there's the use of the CSRF function. You set the cookie to true. That's basically saying I want to use the cookie method, and then you can just use it for the rest of your code. But that's not what the bank did. The bank wanted to use the synchronizer token method, and I'll show you how that works. So what Bob does after the bank secures the website, he goes to his special bank website and he logs in. All right, and then the hacker basically, if the hacker tries to attack Bob again, and if the hacker sends Bob a malicious link that says, hey, send me money, and if Bob tries to click on it, which is just what happened last time, what happens is it says invalid CSRF token, which basically means Bob clicked on the link. The link doesn't have Bob's token. And so the bank's like, this is sketch. We're not going to let you access, we're not going to let this link work and do what it wants to do. So hacker's not going to get any more money from Bob. Bob can spend all his time trying to get his money back. And everything's okay in the world. Bob got his money, and all is well. So that being said, that's the end of my demo. I'm going to pass it off to Yufa, who's going to talk about SQL.
Okay, yeah. So now that we've talked about like cross-site scripting and CSRF, let's talk a little bit more about like databases and how people can like attack the back end of your website and just drop all of your tables. And then it doesn't even matter if they attack your website, honestly, because you don't have any information left. Okay, so here's just an example of some unsafe code. This code is just directly getting ID from like the URL or output of like some PHP script. And it's just directly putting that into the delete query. And the problem with this is that you see the next line, they just execute it, and ID is not validated. So basically, they can inject any SQL query they want into the ID. They can like add on something to the end, and we'll see that on the next slide. And it will actually just execute what they tell it to do. And you really, really, really don't want to let people do this, because like they can do anything they want with your databases. And generally they have like kind of sensitive information on there. Even if it's not sensitive information, if they just delete your databases, then like you don't really have a service anymore. So yeah. So if we go to the next slide, this is a real life example of what could happen if you don't sanitize your inputs. So see, if you're just like some innocent school, you have all your student records in your little database, and someone just comes in and they name their child Robert Drop Table Students. Very realistic name. His first name is Robert, middle name Drop Table, last name Students. So if you see in the previous example, if they had just put that as the name, it'll match name equals Robert, and then there's another SQL query like added onto the end, drop table students. So if they didn't sanitize their inputs, like this poor school didn't sanitize their inputs, they need to hire better web dev people. Clearly, whoever is in charge of IT needs to be fired. They just lost all of their student records, and that's terrible. So they obviously, whoever made this website didn't come and listen to our presentation. But if you listen, then you can create a website that will not let them just like delete all of your information, or even worse, like take other people's sensitive info out of your database. Okay, so one of the best methods of preventing this is called prepared statements with variable binding. And it sounds really complicated, but basically what you're doing is you're just taking whatever input they give you and you turn it into a string. So over here, if you see, you basically just bind the user input to a variable. Over here in PHP, you use a method called bind value. So if you see the variable player here, you bind it to the post of player, so whatever the user gave you. And now whatever the user input is just a literal string. So if you think back to the XKCD, for the like drop table students, it will literally search for a user in your database called Robert Drop Table Students, which is what they should have done. And if it doesn't find anyone, then it'll just return like whatever, you'll just have to deal with whatever happens when no match is found, but it won't actually execute it as a separate query, which is what we want. So this is something that is just really good practice. You always, always, always should do this when you are trying to like access your databases, use SQL and PHP. And it's basically just defining the code first. You see in the prepare statement, that's your entire query. And then wherever the user input goes, you put a variable like player. You can do multiple of these variables inside of one query, and then you just bind the value that the user gives you, and that will just make your code safe. It'll sanitize the input, the post of players is now a string, and everything is good with the world. Okay, and so another thing that I know Sophia touched on earlier is called least privilege. I'm sorry for the memes on this. Google Images is literally the worst place to find memes. Like they're all so outdated. But basically, the idea of least privilege is just you give your users the minimum amount of privilege they need on their account so that they can get their tasks done. So like, for example, like your normal like pleb account shouldn't have admin rights. You shouldn't be able to like delete delete tables and stuff, because that's just not something that users like need to be able to do. So generally, if users don't need to like write to a table, it's not always possible, but if you limit them to read only where you can, if you limit their view to portions of the database, like Sophia was talking about earlier, don't leave your database settings as the default ones. Make sure you look at your database and know exactly what's happening with all of the info on it. So what this does is it prevents them. So the first thing is that it prevents people from changing parameters to illegal values for them. Like, for example, maybe your application is allowed to run an SQL query with a certain value, but your user isn't allowed to like access that information. But if you limit their like abilities, then they won't actually be able to like do something malicious with that code. And that kind of just leads into the idea of it minimizes the damage of a successful SQL injection. So no matter what you do, like there are ways around different protections, which is why there's so many different methods that we'll like go into later briefly. But if you give them the least amount of privilege, it'll really minimize the amount of damage they can do in a success if they actually successfully attack your site. So like if you look at the memes, if you give everybody root, that little girl is going to burn down your house or your databases, metaphorically. But yeah. Next slide, please. Yeah, so the last few things I said are just like general good practices you should always, always do. These are just some general other types of prevention things. So avoiding JavaScript, I know that previous workshops touched on this a lot. JavaScript is dangerous. So if you can avoid using those wherever possible, that would be great. As Sophia said, use most recent versions of platforms. Just make sure that you're not using like a 2002 version of like whatever thing you're using to host your tables, because it probably doesn't have very good security. And it probably is vulnerable to a lot of bugs that other people already know about, because they tell you like what they patched in every time they like roll out an update. So if you don't update, then you're actually a lot more vulnerable, because people actually do know about these vulnerabilities in your systems. So another thing that you can use are called stored procedures. These are kind of this is if when you define your SQL code first, and then you build the statements with like automatically parameterized parameters. And I wouldn't worry about this too much. I think that the prepared statements with variable binding is definitely a more common thing to do. But stored procedures are another way. You just define the code first, you store it from the database, and then you call it from your application. Another thing that we're going to go into a little more into is called whitelisting your input validation. So for example, if you're expecting the user to either give you input A or input B, but they give you like a string C, then just return an error. Just tell them like, no, like that's not allowed. And we'll see an example of that in a little bit. And then remember, always sanitize your user input. So sanitizing is basically like, we'll see later on, we have this thing called HTML special cars. We'll go into make sure you use the prepared statements with variable binding, and make sure that you follow least privilege. And as this guy is saying, I guess another way to prevent SQL injection is just to not have databases, but not always possible if you want to have a functional website. So these are also valid ways. Next slide. Awesome. Okay. So I'm going to go really briefly into PHP. So PHP, we did a whole entire workshop on it. And I'm just going to go into two quick ways that you can kind of prevent some common attacks. So the first attack is called a path injection, and it's also known as a directory traversal, or like a .. attack, because you use .. to go like up a directory hierarchy level. So essentially what this is when the attacker gives you file name input that actually references an illegal file. So maybe they're trying to traverse up your directory to access a file that they like should not have access to. Or maybe they're even, if you see the code example on the right here, they're actually trying to include like a remote file that they should not be including in this context. So the get statement here is just getting the page, which is not good because they could have anything there really. And the solution, there's two. The first is to check the path for illegal accesses. So if you see on the left here, it's checking if the path has like a .. And if it does, then it just throws an exception saying that you tried to traverse the directory, like that's illegal. Go to jail. No, I'm kidding mostly. And then on the right, they have the same type of like checking the get string, but this time they're checking for remote file inclusion. And again, if they're trying to include something that they shouldn't be, just throw an exception, just don't let them do it. And another solution that I talked about earlier is whitelisting files. So basically what whitelisting files is if you see, they have a list of allowed files. So this is probably like the 4 pages in your website: home, blog, gallery, catalog. Any other pages, I'm assuming, are just like you should not be able to access them if you're a normal account. So they're going to take whatever the user gives them as the page, and they're going to check if it's in the array. And if it's not in the array, then they shouldn't be allowed to access it. And if it is, then we're all good. Like we checked against the allowed files, and we figured out that like they're not trying to give us a file that's illegal to them. Next slide. Oh, awesome. And then this is another, I know that Arun talked about cross-site scripting attacks. So over here, you see an example where they inserted a JavaScript script into the URL as like maybe like the output of a PHP script. So when you get it, when you run get search, it'll actually get like the JavaScript. And if you're not careful and they don't have just some benign like alert test, it could be really, really bad for your website. So a solution to this is to use HTML special cars. So this is essentially just another way of sanitizing your input. And it does the same thing as the prepared statements of variable binding in that it just turns it into a string. So instead of having it as like a JavaScript script that you can run, it just becomes a literal string. And that kind of like negates the danger that it poses to your program. So instead of running a JavaScript script, it'll literally search for like open bracket script, close bracket alert test. So that's like much less dangerous. And there's a lot of different PHP vulnerabilities, as I'm sure you guys all went to our last workshop. But if you're interested in seeing other ways that you can prevent different types of attacks, we have a page right here that has a lot of different attacks and solutions to them. All right. So thank you guys for coming. This is our attendance code with some solid life advice. And we have a Kahoot, actually.